In this talk, we're going to talk about Android from the trenches. This is the experience that I've had over the last 3 years of having 2 applications listed in the Google Play top free category, and all of the interesting things that have happened over the last 3 years and the lessons that I've learned. So let's talk about kind of my background a little bit. My name is Donn Felker. You can reach me on Twitter at Donn Felker. You can see at the top there, or you can reach me on my website, donnfelker.com. I've been running Android applications since around 2008 when the first Android device came out. I originally started writing some various different ringtone applications and moved on to some camera-based apps and just tried a bunch of different things with the platform when it first got announced because I was fairly familiar with Java. And throughout the years, I've become quite fluent inside of Android, and as you can see here, I've written a few books on it, starting with the first Android application development for dummies and ending here with Android development tools. I wrote one of the chapters in that book that's based on Android Studio. That book is by Mike Wolfson. It was released late last year. So over the course of the past 6+ years, it's been quite a wild ride, and I have had my applications and my source code listed in hundreds of millions of devices. And I've seen Google Play start from a small little app store or market called the Android market and turn to what it is today to Google Play. So let's talk a little bit about Google Play. Google Play is now a humongous monster of applications that contain anything from entertainment all the way to video recording to anything that you can maybe use, like a Walgreens app to get updates on your prescriptions, to manage your bank accounts, anything of that nature. Previously, the Android market was very small. When I started, it was very easy to get your application inside of the top free category. And they actually had another category at the time that's kind of come and gone a few times now. And that was the most recent. And that was the most recently released. Because back in the early days, before there was even 1,000 apps in the App Store, you could release an application. And inside of the free category, your app would stay in the most recent list for a few days. I'd probably say about 5 to 7 days your application would just be listed as soon as you hit a tab inside of the Android market, because there were so few apps and they were not being published that often at all. And so the availability of apps was very small, and so everyone usually tried almost all the apps that were out there or anything that was interesting to them. So it was very easy to bubble to the top of the Android market at the time. And now that we've moved over to Google Play, we have books, we have music, we have movies, and of course we have the apps, which is what we're talking about today. Google Play has hundreds and thousands of various applications, games, and so forth. But my experience has been inside of Google Play has been quite an exciting ride. And 2 of these apps have been inside of the top 100. And these 2 apps are MyFitnessPal, the calorie counter app, which is the #1 health and fitness app for Android at this time inside of Google Play, and also Groupon. And so if you actually go inside of Google Play at this time, and you can even do it on the web, go to the web and go to the free category, and you can look at the top charts, you'll actually see that Google and MyFitnessPal sit currently at the top. Now this screenshot is about a week old in April of 2014, but this is currently where it sits. Right now you can see that MyFitnessPal and Groupon share the same likes of Dropbox, and we have Chase, Bank of America, Walgreens, and various different games, and Wells Fargo, Cut the Rope for a game. Now above this, of course, a couple of rows up are the top 5 and so forth, top 10, and that's where you're going to see the Facebooks and the various different chat apps and so forth like that. But you can still see we're still inside the top 100. And when your app gets inside of here, various different types of things can happen. And so what usually happens when I tell someone that my apps have been featured or are currently featured inside of the top free 100 on Google Play, the first question that gets asked is, well, what happens when your app gets to the top free category on Google Play? Well, it's a very good question. And to tell you the truth, quite a few things happen. And here's what really should happen. Because when you get inside of the top free 100, a lot of things are going to happen. But here's what should happen. The first thing is you're going to have a ton of excitement. I mean, you just made it to the top 100 free on Google Play. You are literally sitting at the creme de la creme of Android applications. This is a super exciting time. You probably have your entire team, you yourself are dancing, having a good time, thinking about it. You have all kinds of joy. Everyone's maybe having a few drinks, getting excited. And the big thing is if you have monetization, and what I mean by monetization is if you have ads, or if you're selling a product like Groupon sells coupon deals, or if you're selling subscriptions you're selling a subscription service of some sort, maybe a newspaper, or you have in-app purchases because you have a game and you're selling in-app coins or anything like that, then here's what you can expect. You can expect to go ahead and let it rain. And all I'm talking about by that is money. It's coming down. It's going to come from the sky. It really is. Being at the level where Google Play is now, a lot of money is going to come pretty fast. You will see a dramatic spike inside of your analytics. You'll see all kinds of different kind of stuff happening. It's like it's going to be raining. It'll be raining cash. So that's one of the best things that can happen for you when your app gets inside of the Google Play Top 100. Now, I'm not going to look you in the eye and tell you it's all roses, because it kind of is, and it sometimes is and sometimes isn't, but it might not always be roses for you, because you see, the thing is, here's what really happens when you get into the Google Play Top 100 free category. Of course, you can have your excitement. Everything's going to be good and golden. You're going to be all joyful and everyone's going to be dancing still. And if you got that monetization, you're going to be throwing the dollar bills out and letting it catch it inside of your big plastic bags and throwing it over your back like Santa Claus. And so you just be collecting your money. But then, all hell breaks loose. Everything hits the fan. And here's what I mean by that. There's all kinds of things that can possibly go wrong that you weren't expecting. And that's what we're going to kind of talk about here for a few minutes today. One of the things that you can also have happen to you is you're going to get a ton of email. And these could be complaints. They could be compliments. They could be crashes. They're going to be support emails, feature requests. It's going to seem like a tidal wave of email. And if you're not ready for you, it's going to be completely overwhelming. You're not going to know what to do. And you're going to think, well, what are these crashes? These never happened in dev. I don't even know what the stack trace is here. What is this soft sync exception from Android music player? Like, I'm not even using this. The weird thing is you're going to have weird crashes that you've never experienced in your entire life in development. There's going to be crashes you cannot replicate for various reasons because you're at such a large scale. And so the big question is at this point is, how do we mitigate these types of crashes? Because crashes are really going to kill you if your application reaches the top 100. If you reach the top 100, you're doing okay. Maybe you've released an update. Boom, all of a sudden you start having a lot of crashes. Your SEO ranking inside of Google Play or your actual just category ranking will tank as well. If people start uninstalling your app, Google watches all of these metrics and helps them with their algorithms behind the scenes determine who's going to be in the top and so forth. So you want to keep your crashes at a minimum. Keep them under control. So how do we be proactive about it? Well, one such way that we always are proactive about things inside of software development is to do proper unit testing. And so inside of Android, we're talking about a few things that we can do, but one of which is going to be using JUNIT with ROBOLECTRI and MOCKITO. Now, ROBOLECTRI and MOCKITO are two different frameworks, two different libraries, and MOCKITO is a mocking library for Java, and ROBOLECTRI is kind of like this little shim that you can kind of use to interact with Android in a unit testing environment. Android wasn't really built with the unit testing in mind. Everything has a pretty hard dependency on the Android context and various different pieces of Android itself. So if you want to test Android components, it's really hard because you need the actual Android runtime, and you either need to run really slow integration tests, and if you want to have fast iteration, you need to speed it up a little bit. And you can use MOCKITO, ROBOLECTRI, and Android, and it creates a much better user experience. Now, the thing is, I'm not going to say that it's perfect because it's far from perfect. ROBOLECTRI itself, when it works and does what you expect it to do, is a phenomenal tool. However, when it doesn't work, everything goes wrong. And you can literally spend a day, 2, 3 days trying to write your own custom ROBOLECTRI shadows because part of ROBOLECTRI hasn't been implemented. Now, what ROBOLECTRI does is basically re-implements part of Android so that you can unit test it using some crazy reflection and all kinds of cool stuff. Get in there and check it out if you really want to learn some cool Java code and see how they're actually doing that. But let's just take a look at a quick example using JUnit and ROBOLECTRI and MOCKITO here. So here's an example of how we can maybe test something to help us make sure that our application is doing what we expect it to do. We're going to use a ROBOLECTRI test runner at the top. Instead of using the JUnit test runner, we use the ROBOLECTRI one. And we're going to call this class some value service implementation test. That's just some random name we threw in there. We have a couple of fields here. One's a user value service and one is a user service. User value service gets some values around the user, maybe like their weight and their height and their goals and so forth. The user service gets the information maybe about a user. It could be their password, their username, and then it could be kind of the facade layer that gets into everything else. Now, because we're using constructor injection, which we'll talk about in a moment, I can actually inject dependencies into the user value service. Now, this is the third line down here inside of the before annotation in the setup method. We'll see UVS equals new user value service. That's the third line, the bottom line on the setup method. And we're passing in a user here. Now, if we walk back to the top of the method here, we'll see that we're actually creating a mock of the user service class. And that's using MOCKITO. So we're having MOCKITO create a mock of the user service, which is just an interface. And then what we say is, hey, anytime, the next line says, hey, when someone calls user.getGoals on this interface, I want you to go ahead and return a new mock user goals. So it looks like the user goals return something like user goals itself. And so we're having a mock return another mock itself. So we're getting kind of complicated in the mocks and stubs here. But you could actually see that we're actually mocking things out, which makes testing a little bit easier. So we're using some regular POJOs, plain old Java objects. So the before method, of course, runs before every unit test. So now that this has been run, we can go ahead and execute these. Should be able to get basic weight and height info unit test here. And that's the test that is annotated with the test attribute. The name of the test follows a common kind of a loose behavioral driven design naming pattern where you kind of specify what should happen and what you are expecting to happen. Just by reading the test name, I'm kind of understanding what the test is doing. I should be able to get the basic weight and height info, and because I'm working with users, I can kind of understand it's about a user. Now, inside of this method, we have a couple of extra things here. We're actually setting mocks inside of this method as well. So we're saying when the user.getGoals is called and getHeight is called on that, I want you to go ahead and return 1223.00.12f as a float. Next line, when user.getGoals.getWeight is called, I want you to return a string in the format of 1223 grams. And then what we're going to go ahead and assert is that our UVS, so we say assert that UVS.getHeightGoal. Now remember, we are going to actually testing here the user value service because that's what we did we constructed inside of the setup method. We want to see that, hey, when we get the user height goal, we want to actually see that it's equal to 1223.00.12f. And so we're actually making sure that we're actually having these mocks interact. So we're actually doing some interaction-based testing. So you have state-based testing to make sure that, hey, if I set the value to 4, it's actually equal to 4. You have interaction-based testing and to see that these values are actually being returned as you expect. Now, we're actually not verifying any interactions. You can actually tell MOCKITO to actually fail the test if for some reason user_goals.getHeight was not called. Well, then it should go ahead and fail because maybe some developer hard-coded a value, forgot to return it, so you want to test those interactions. So MOCKITO allows us to do stubs and mocks. So if you read the article by Martin Fowler, stubs versus mocks, you'll actually see what the differences are, one being state, one being interaction-based. And so here we're using mocks to kind of get us going down the proper road of doing state-based testing, but we can also do interaction-based testing. And then the last line, of course, does the same similar thing. We check that the user weight goal is equivalent to 1,223 grams. Now you may notice a little bit different syntax here. We have assert that and some value is equal to some other value. So let's take a look at assert that. So the big question is, what is this right here? Assert that something is equal to some other value. Now what that is that's not typical JUnit assertions. These are actually FEST assertions. And FEST assertions is an open source library that you can use to write assertions that make a little more sense. So let's step back again, look at the previous slide, and we can see that I can actually read this assertion pretty easily. I'm looking at the last one here. It says assert that user value service, UVS, assert that user value service dot weight goal is equal to 1,223 grams. So I was actually able to read this very easily. I didn't have to have any type of commas specifying some value, comma is something else. It's just much more readable and easier to follow. Now the great thing is the team at Square has actually extended FEST to use Android, so you can do tests for intents, bundles, extras, activities, all different types of Android tests. They have extended FEST, so you can use that same type of syntax for assertions, and you can learn more about that at github.com/square /fest-android. And so now we've written some unit tests. We kind of have some stuff written around our app, so we're pretty sure what it's doing, but still we're not covered 100%. So we can use another testing tool that Google has released called Espresso. And this is Google's testing tools for Android. And let's just look at a quick example. One example being, maybe we want to click on a spinner. So again, you click on something, a list of items opens up, and you want to select an item to verify that the text on the item is exactly what we expect it to be. Here, it's very almost similar to Fest in the way that it reads. So we want to say on the view with an ID of r.id.spinnerSimple, I want you to perform a click event. And so that's basically saying, okay, click. And so it's going to click on the spinner. Now the spinner is going to open up. And now we want to say on the next item, click on the item Americano. On the data, all of the instance of the string class is Americano. I want you to perform a click. So find the one that's Americano and perform the click event. And then the last one says here, verify that the text view contains a string Americano. So we want to make sure that the actual string value of this, not the data, the string value is Americano. So on the view with an ID of r.spinner_text_simple, check that we match text that contains Americano. And so we can actually verify that the actual visual representation is exactly what we expect it to be. And this is really nice because now we can actually start doing, this is interaction-based testing. This is the actual code that's running on the app. The UI is running, and Espresso is executing against that. This is very similar to Robodium. If you've used that before, Espresso is kind of the next generation of what, if you were using Robodium, would be. So take a look at Espresso if you haven't tested that out. Now the next step is to, all right, we've kind of done this, we've kind of manually done this. Let's figure out a way to even do some more automation, how to even do this a little bit faster. So what we can use is we can use Monkey for Android. And we use the Monkey runner to run tests against your Android app and devices. And what Monkey does is it simulates a bunch of random events and throws them at your app. And you can specify how many events to throw at it. It'll perform screenshots, turn the volume up and down, swipes, press buttons really fast, open different menu commands, open and close screens. And what this will do as the iterations increase, your app will actually, you'll start to find weird edge cases arise. Maybe you forgot to close a cursor somewhere. Maybe you're not releasing a bitmap. Something happens, you run out of memory, you don't close something, you get a crash. Monkey Runner helps you find that, and Monkey is a great tool to do that. And so here's an example command of what you would use to run Monkey against the Instagram application. So on your phone, if you had Instagram installed, you would just run the ADB command, ADB-D shell Monkey, pass in the package name, which is com.instagram.android, and then we want to run it for 2,000 iterations. So I want 2,000 events thrown to this screen. And an event could be a button click, could be a swipe, could be a scroll, could be anything that would be interacting with the app. And then what you'll actually see when your device is plugged in or on your emulator, you actually see the events being taken place and crazy things will start happening. So if we take a look at the next screen, this is the exact command being run against the Instagram app that's running on my phone, and I'm logged into my account. Now we'll see it run here again. We see it's turning up the volume, it's refreshing, it took a screenshot, turning up down the volume, and then all of a sudden Instagram just crashed. So actually, only with 2,000 iterations, I actually crashed the production Instagram app. Now what the error is, I can go take a look at the ADB logs, and if I'm in development mode, of course, and I was on the Instagram team, then I could actually see what maybe crashed the application. But now, as a recommendation, 2,000 iterations is not many at all. I highly recommend if you're releasing a production app that you test your application with 20,000 or more iterations. Just let it run for a little bit, and you'll find some really weird edge cases. Maybe where you're not letting something go, and eventually after enough interaction on the app, you get an out-of-memory exception, or you get something else happen. And users will run into these situations when your app is at scale like this. So Monkey is a very good tool to find these really weird edge cases. All right, next let's talk about automated acceptance testing. Now, there's a bunch of different tools that are out there for this, but one that I've seen a few companies use now is Appium, and this is at appium.io, and it's automation for apps. Now, what this uses is the Selenium WebDriver and uses the JSON wire protocol. And so you can actually write your tests in the language that you prefer, and you actually see if you go to appium.io, you install actually a Node module, and you can actually write your tests in JavaScript if you want, or you can actually write them in native Java or a language that you prefer. and you can write your tests in that framework. And then this is what a lot of QA teams will write their acceptance tests in to help them automate a lot of their acceptance processing. Now you need to make sure that your views all have IDs and everything, so that's a little bit of work that you may have to go through. But for your QA team, once they get up and running and they learn to use this and all of your views have IDs, this will be a huge time saver for you and your team, because you're able to catch a lot of stuff if you have a QA team. So I definitely would take a look at Appium or any of the competitors to Appium itself, as I've seen a lot of them work. Now again, we're still not perfect yet. We still haven't solved all the problems, because if you're an Android developer, you know that you have developed an application and you have run it on your device that you normally use. Maybe it's a Nexus 4, a Nexus 5, Samsung S4 or whatever, and it's your main device. It's what you use to develop on. You're familiar with it, and your application works perfectly. But the problem is, as soon as you install your application on another device, it immediately blows up, and you're not sure what the problem is. And so you end up figuring out that, all right, well, I've fixed it on this next device, and then you go install it on a 2.x device because you're supporting back to Android, Android 2.x, and you see it, and all of a sudden it blows up there. And so you start witnessing firsthand the problem of Android fragmentation, all the various different differences. And when your application is released at scale, you're going to run into all kinds of crazy errors. And even more so if your application is internationalized and you're released in countries like China and various different, the symbol languages itself, Chinese, Korean, Japanese, and so forth. You're going to run into really odd devices you've never seen or heard. The amount of Android devices grows daily. And so when I first started, there was, one device, and then eventually it went to 5, and then it went 10, then 50. We're in the thousands at this point of various different devices. And so it's not that one device is the problem, it's that every single one of them is the problem. And the problem is testing on multiple devices just sucks because it's a real time sink, but it's something you have to do. And usually what I recommend is finding all the devices that are kind of obscure, that don't really, like, your app doesn't really look good on. And this could be a really weird aspect ratio. This could be a device that's very hard to find. This could be a device that is not common at all. Find a bunch of those devices, and then also get the high-end devices like the Nexus devices and test on those. If you can test on these weird off devices and then also on the high-end devices, and it looks good across the board, you're probably covered on the good 80-20 type of rule, meaning that you've tested with the 20% you think is the general consensus of across the board. And then you can get hopefully the 80% of results that you're looking for. So following the typical Pareto principle. Now, it still doesn't mean that testing on multiple devices isn't great, because it still sucks. And the one thing is, you really know you're an Android dev if your desk looks like this. And just right now where I'm recording this, looking at my desk, I have 8 Android devices sitting on my desk right now. And the desk next to me, I have 4 other ones. And so I have various wires all over the place to test various different applications, and it kind of looks like the image that's in the background here. We have all kinds of devices on the screen, on the countertop, and we're testing, and we have a big old jumble of wires, and your desk looks like a mess, and it's just kind of crazy. And so one nice thing that I recently found is a tool called Device Lab, and it's by a company called Vamico, and you can see it at devicelab.vamico. Vanamco, not sure if I'm pronouncing it right, but that's the URL. But if you can go check out Device Lab, you can actually store, looks like 6 regular devices here. You can see there's an iPhone and a couple of Android devices up there. And in development, you can also perhaps put a tablet there. So it's a nice little stand that allows you to have various different devices running up on your desk. And now you can use ADB, and you can deploy to all these devices and test at once. So maybe you make a change, you want to see it across the board, then you can do that. The one stickler at this point is, if you're running automated testing, such as like Spoon, or you're running Monkey, or anything like that, that's going to be using a lot of processing power on the devices may get hot. So if you're running a test that takes maybe all of your UI automation tests, and it takes 30 minutes to run, and you go to lunch and you come back, you may end up finding that one of your or 2 of your devices have fallen off of the Device Lab because they've gotten so hot that they've melted the back of the Velcro that's attaching them to the Device Lab actual unit itself. You can see that the wires are hidden very nicely behind the scenes, so you don't have a huge mess of wires. So it's really nice to use. Just a little tip if you want to clean up your desk a little bit. So it makes it better, but at the end, testing on multiple devices still sucks. Now I said, remember, we want to test with Monkey, and we might use something that processes a lot of processing power, and we're using ADB to deploy to many devices. So this is where we can kind of rely on ADB and a tool called Spoon and see what it can do to help with our testing process to make sure we don't run into these huge crashes. Now you see we've gone through a lot of these. We've gone through unit testing, we've gone through QA acceptance testing with Appium, we've done Monkey Runner, we're talking about using a device to hold your devices up, a device stand I mean. And then now we're going to talk about a little bit of automated distributed instrumentation tests. So you're going to run your multiple devices. You have your device lab up here running. You have your 6 or 7 devices you think kind of cover the vast majority of your use cases for your market of users. And then what you can use is you can run the Spoon app. And what you'll see here is this is a screenshot from the actual square.github.com/spoon site. And what this is actually doing is running unit tests, these integration tests and acceptance tests across various devices. You can see we have Droid Bionic, HTC One, Nexus 4, Nexus 7, Nexus S. And all the green lines mean that these are tests that pass. You can put your mouse over them, and as you can see here, and you can see what the test was. Password was too short, shows an error, looks like the test passed. Excellent. You put your mouse over the red ones, it'll show you these are the tests that fail. So you can see here that on various devices, some tests passed, some tests didn't. This helps you kind of catch some of the fragmentation issues. And Spoon gives you that visualization and this graph to see this. Now, Spoon is an open source library written by the Square team that help with acceptance testing. And here's a couple more screenshots of it. So we can actually see the screenshots of the actual device here. So in the foreground, we have the Nexus 4. And as things were happening, Spoon takes screenshots and records them and outputs them to this nice little HTML file here that we can inspect after the tests are run. So we can actually see the state of the UI on that device after it's been run. So this is pretty nice. So if you have a bunch of devices, maybe even have a device lab, you can have Spoon automate across the device lab and see your various different changes, actual and not real time, but actually in what the physical screenshots look like inside of those devices. And then you can actually see the errors in the background. You can see the Nexus 7 had a JUNIT framework assertion failed error, and you can go inspect that to see what the problem might be. And then at that point, go debug on the Nexus 7 to figure out why is it failing here, but not on the Nexus 4. So Spoon, we had Appium, we got JUnit, we got ROBOLECTRI, we got MOCKITO, we got Fest assertions, we have Monkey Runner, we have all different types of things. But the thing is, we can't catch everything because, as the statement says, even parachutes have holes. Things are always going to fall through. I mean, you're not going to catch every single thing that's out there. So the thing is, what I'm trying to say is that this still happens. You're still going to have these explosions, these things that you never thought about. You've tested your code completely, but maybe you've included an ad network inside of your application. So, you can let it rain. You can get that monetization flow going. But for some reason, maybe that's what's blowing up. And I have seen this firsthand. A mobile ad network's application will just continue to start blowing up. And so one thing you can do to help stop that is implement a tool called Crashalytics. Now, Crashalytics gives you a little free SDK, and this is free to use. Crashalytics was recently acquired in the last year by Twitter. And we use this at MyFitnessPal. And from the looks of it here, it looks like Groupon uses it as well now. What you do is you implement the SDK inside of your application, and then what will happen is Crashalytics will log caught and uncaught exceptions. So what this means is if your application is running and a user perhaps does some type of interaction and your application crashes, immediately the crash will be reported to Crashalytics. At that point, you can log into your dashboard and get email notifications as these crashes are occurring. And then different severity levels will start occurring as a crash starts climbing out of control. Maybe you recently released an update and all of a sudden you have, 100 crashes or 100,000 crashes. You'll start seeing these notifications that the severity level of that crash has been raised. Crashalytics does that for you for free. So let's take a look at this next screenshot. This is actually a screenshot of one of the dashboards I have access to for one of the apps that we run. And you can see here that up top we have 27,000 different issues across all the versions of this application. We have 1.7 million crashes, and we have 727,000 affected users. This is what it looks like when you get to the top 100 free category on Google Play. You have an insane amount of traffic and an insane amount of things are happening. And the key thing I want you to notice here is the second and third highest crash here are crashes that are not our code. These are crashes that are from com.mobileapptracker and com.adobe.flashplayer. This code we didn't write. This is part of a ad framework that we use that has a crash in it. And so this actually crashes our app on occasion. And it's we're at such scale when you were inside of the Google Play Free 100 that you end up crashing your application a lot sooner. Excuse me, not a lot sooner, but you end up crashing it a lot more. And so you can actually take a look at these, and if we were to drill into one of these, and this is what it would look like. And we can see here we've released maybe an update on around April 4th or something like that, or April 3rd. And then all of a sudden we peaked out. We didn't have any crashes. Now all of a sudden we had almost 8,000 crashes with this line of code that we had written. And we can see the various different devices it's impacting. 49% of the crashes are on Samsung, 14 Motorola, 23 are on HTC, and the other 23% are all mixed. 89% of them are on Android 4, 10% are on Android 2, and less than 1% are on Android 3. And then it's different variations, Android 4.1, 4.4, etc. You can see how many are rooted. 5.53% of the crashes are rooted. Devices, we can see how much free space the device has. This is all very useful information because we can actually determine that maybe this crash only occurs on Android 4 when we have over 89% memory utilization. So we see we have 955 megs of free RAM as the average. And then you can actually drill down into the stack trace down below, and you can view it in the raw format, or just take a look at, here's the crash, and it looks like it was on tooltip job line and tooltip something.java line 230. That's where the crash occurred. We can then go take a look at it and try to figure out what's going on there and why it's occurring. And then we can go ahead, and once it's done, you can go up here to the top right corner and click the open and close button, and it'll put a little stamp over it notating it's closed. Down at the bottom, you can actually add notes to it, maybe put a link to your ticket inside of your ticketing system like Jira or Pivotal Tracker or whatever you use. And this is very useful. Another very useful thing, if you're a consultant or you're an agency, is that they have the concept of organizations inside of Crashlytics. And so since I'm a consultant, I have access to various different projects. I have access to a gaming company I'm part of called Conquer, and we have a couple apps there. I'm part of Agilevent, which is my consulting company, Get Human, which is a client of mine, MyFitnessPal, Agile Medicine, which is another company I'm helping out with, and some other organizations inside of here. And so we have various different applications, and we can see how many people are part of each one of them. And so it's really nice that I can actually have one login and have access to all of my different applications that I'm part of. Now, one of the things when Crash Tools originally came out that you had a problem with is you would have your crashes from development showing up inside of your crash tool. And this happened in various tools like BugSense or your own custom crash logging and so forth. And so what do you do about development versus production crashes, and how do you avoid getting them confused? Well, what I've done is I've come to migrate everything over to use Gradle as the build tool. And what I use is Gradle build variants inside of there. And so I have a couple different variants, and here is part of the build.gradle file. And what I have here is a debug variant, and what I do is I add the package name suffix .debug to that. And so what it will do is add a .debug to the package name. And then release, I just do regular, I use DexGuard for one of my projects, and we obfuscate with DexGuard, and I don't add any package name suffix. So what does this mean inside of Crashlytics? Well, if we take a look inside of Crashlytics, we could see here in the Conquer application that I have com.conquer, which is the production app right now, which is in a private beta. And then I also have the debug version, which is right below it, com.conquer.debug. So now we can see the one that's highlighted in blue has 347 crashes that I need to take a look at or be concerned about across all the versions. And then I have the debug version, which there's 16 crashes, which is I'm not really too concerned about because it's in debug. I probably know that they're happening, but I can still track them. This is very useful because you can create various different build variants. So you can create a debug, a release, a QA build that only your QA team gets, and you could have released through your continuous integration server. And so if they say, hey, we're getting some errors on our app, can you take a look at it? You can go inside of Crashlytics and even see, hey, it looks like the QA team is having all these errors. Let's see what's going on. And that's kind of how you can also dog food products internally as well. So that's Crashlytics in a nutshell. It's a great product. It's something that I always use and recommend every person use since it's free. You get so much usefulness out of this product, and you can be more proactive about your applications and throughout time. So definitely check out Crashlytics, download it, install it. You can use it for iOS too. So if you have iOS applications, check it out there. And the lesson that we learned here is just watch your crashes. It's something that's huge. Another thing you can also do to help with this is also watch for in-app monitoring. And New Relic provides an SDK in which you can plug inside of your application and start getting metrics like this. Now, this is a screenshot from their website, and I believe this is a iOS implementation screenshot, but the concepts are all the same. We have the execution time graph, which says in the brown, says look why we spent most of our time communicating over the network. The purple means that's the amount of time the view loading, and then the database is also on the bottom in kind of a teal looking color. The key thing to know here is the slowest interactions on the bottom left corner here. You can actually click on these links. It'll drill down into the slowest interactions of your application. So you may actually think that the slowest point of your application is the HTTP communication. But maybe you didn't realize that a developer forgot to remove a thread.sleep command for 5 seconds because they were testing concurrency. And they forgot to remove it, and it shows that the average time is 6.5 seconds to perform a local operation. Well, that doesn't make any sense. You can drill down, take a look at it. It'll show you the line of code or where the area is at that you need to investigate to speed up your versions. They also show HTTP response time, HTTP errors, network failures. Now, this is a commercial product, so it kind of goes according to your budget and so forth. But this is a very useful tool. I use New Relic on all the server applications that I build inside of Node.js and Node.js and Rails and so forth. Very good tool. Check it out. Would love to have it in a lot of applications that I've written before. So now let's get back to this one screenshot here. Managing tons of email. You're going to get your application in the top free 100 on Google Play. You're going to get a ton of email. That's just going to happen. It's just the reality of the situation. And the big deal is you need to manage your email load. And the best way to do that is not through just a typical Gmail account that's set up through Google Apps for Domains and having 8 people log into it. Not at all. That's impossible. You're going to fail and you're going to fall hard doing that. The best thing you can do is do some type of case management application, do auto assignment, has some type of email workflow, and more. And what I mean by this is there's various different tools out there for this. Now you can use tools like Help Scout, which you can actually come in here and start seeing how many customers have you helped, how long does it take to respond, and so forth. You can also use tools like Desk.com and Zendesk. And what these allow you to do is say you have a email address like support@mycompany.com, and you set the email account up to go to these different services, and then you can have your team log in. So I can have Bob and myself and someone else. We all have accounts and we log in, and then we can start handling the email support load and actually watching all these cases. We can tag them, we can assign them, unassign them, we can have different workflows around them. So if it's not handled, then we can handle it. And as we see here on desk.com, we can see that they're actually interacting with Twitter, they're actually interacting with phone, Facebook, and so forth, and email. And so they're doing all different types of interactions, so you can actually work and help consume and support your customer base much easier if you're using a tool like this. Some of the tools I recommend when you're implementing this and getting ready to support your application, if it's getting very popular and hopefully hits the top 100, are going to be Zendesk, Desk.com, Freshdesk, and of course User Voice for some good FAQ, and they also have some good stuff in there. There's a bunch of other competitors out there as well, like Help Scout is another one of my favorite ones as well, and you can check them out as well. So now let's talk a little bit about defensive coding, because one of the things that we're trying to do is we're trying to prevent this explosion from happening. Now, one of the things that you're going to notice a lot when your app gets in the top free 100 is you're going to be riddled with this error right here, the null pointer exception. And so I'm just going to call that the NPE, because you need to understand that the null pointer exception is now going to be your new best friend, because this one is actually probably pretty easy to fix. You just need to check for nulls. But what you don't really expect is the things that shouldn't be in production, the things that shouldn't be null, are going to be null. And I say thanks Murph here, so for Murphy's Law, because Murphy's Law says whatever can happen will happen. And that's the truth inside of a large-scale production system, especially one where you've reached the top 100 free in Google Play. The things that shouldn't be null for some reason are going to end up null. And now the biggest thing that you're going to find, I see this in every single large application, small application, it slips by every developer for some reason, is this simple example here. This is an example where we're clicking on a list item inside of Android. And then the second line says toast. We're going to make a toast that says, hey, says seems legit. And we're going to show it, right? Well, seems legit, right? Doesn't look like anything's going to happen. I wish. See, the thing is, inside of fragments, we have this thing called getActivity, and it gets the activity which this fragment is a part of. The recommendation is to make sure you always assume it's null. In development, almost always it will never be null. Almost always it will work out perfectly, but there's always the chance it could be null. And unfortunately, a lot of developers don't check for null inside of their application or inside of get activity. And so the easy fix here for these MPEs is just to check to make sure get activity is null. It's the easiest fix in the world because this happens in every single production application I've seen for Android, and it's a majority of the crashes you see in Crashlytics at first. So the big lesson is just check for null. And this could be for get activity, and that's the big one. But it's also for any time you're working with lists or something inside of an object graph. You need to say, person.get, .get orders, .get order 5, .get line items, get line item 2, all the way down that chain. You need to be checking for nulls. Even though it shouldn't be null, it's possible that it could be. When you're at scale, various things are happening. Activities are being torn down. Services are being killed off. The Android system is getting hungry for resources. It starts killing off your app. Various things end up in various resources. User hits home. They hit the reset button. They go back to your application. Your app's not in a state that your app doesn't expect it to be in. It blows up. You need to check for null. That's the big thing there. Second thing is, we need to worry about software patterns. See, software patterns keep you and your team sane and somewhat healthy, because we've all been experiencing this scenario here. The boss man comes and says, hey, the app has to have this feature in this release, and I know you just heard about it this morning and it's 10:30, but we're shipping this afternoon. It needs to be in there today. I just got the phone call with the board or whoever, the stakeholders, and this has to be done. And so they come to you as a developer or the development manager and say, hey, this has got to be done. And so what do? You go inside your office and you make a quick, easy update. Hey, it's done. Quick, come in. And you know what? Hey, since it compiles, you know what? Let's go ahead and ship it, right? That's what everyone says. So what happens is the boss man, hey, he's happy. Your teammates, though? Well, they kind of look at you like this. Seriously? Did you just ship that? That's the problem here when we start shipping things real easy. What we end up with is this huge spaghetti mess. Just today, I was working with some code where I needed to implement a parsable inside of Android. I fixed one thing, had one squiggly line. I said, I'll just fix this real quick. As soon as I dove in to fix that, I realized that this was the tip of an iceberg that touched over 40 files because of huge spaghetti mess stemming from one change that one person just kept building upon and never went back to fix. And it was a humongous spaghetti mess. So the big thing is we need to worry about this, and we need to worry about making these quick changes that aren't tested, that aren't documented properly. And even though you may be hard coding something, there could be a problem when your app is at scale. Because the big thing is when your app is built upon a cardboard foundation, it's only a matter of time before it gets damp and falls down and falls. And that's going to happen, especially at scale inside of the top 100. And even if it doesn't, you need to prepare, because all it takes is your application to be featured on Lifehacker for you to just uptick a lot. I've had a couple of my apps featured, just my own personal apps featured in Lifehacker on a whim, not even advertised. I just found out through just seeing traffic hit my site and backtraced it to an article on Lifehacker. And so luckily certain things I had done made the app architecture work, and I was able to make changes fast. And so what that means is I was able to make these changes fast, but appropriately. So app architecture does matter. And what I mean by this initially is it's just big on software patterns. And the big first software pattern I always recommend everyone worry about is dependency injection. Now, dependency injection means you can inject things via the field injection, constructor injection, method injection. But what it really does is it breaks apart dependencies. Now, one of the problems with dependency injection frameworks inside of Android, and this has been a problem since it started, is that they're slow. And this is said by Roman Guy here recently. He said this at DevOps. He says, startup time slowed down by 30% because of an injection framework. That's what Chet and I warned against at DevOps. If you just Google startup time slowed down by 30%, you'll actually be taken to this tweet, and you can click on this link. What it says is basically is Facebook used a popular dependency injection framework, and I am suspecting that it's RoboGuice because I'm a committer on RoboGuice, and we know that they used it inside of Facebook Messenger. And there was the 30% slowdown because of all of the reflection. And so that became a big problem. Now, one thing you can do to get around this issue is you can not use reflection. And to do that, you can use a tool that Square created, and it's called Dagger. Dagger is a new type of dependency injection tool, and it doesn't use a lot of reflection. What it does is actually compile time code generation by looking at annotations. You say, I need to inject this field, and then you set up these different modules, and at compile time, it does a bunch of checks to make sure that you've wired up everything correctly, and it will actually generate the code that does the injection for you. So you actually have real Java code that is actually created, real files at runtime. They're created and included inside of your application to help speed up the process. But you get the benefit of development using dependency injection container. And you can also do different composition patterns with them as well. So let's take a little quick example of using Dagger. Now, one of the things that you're going to think about is, I need to use it with Android. That's what we're here to do. Well, Android is not built around dependency injection at all. It's not even friendly with it at all. And so we have to do field injection, unfortunately. I usually prefer constructor injection, which I'll talk about, but to work with Android, we have to do field injection. And here's an example from Android Bootstrap. We have which is an open source library. We have a news list fragment, and inside the news list fragment, we have two things that are injected here, a Bootstrap service provider and a logout service. We have two inject annotations, and it says inject this. Now instead of on create, we see injector.inject this. And now what happens at compile time, Dagger goes in there, looks at the injector.inject, finds the injections, and then what it does is it rewires part of the app and builds these additional adapter classes that actually wires everything together for you. So actually create a new logout service, create a new Bootstrap service provider service, and all the object graph that's associated with it. So it actually builds it up much faster. This provides you a lot of flexibility. Now, since we're on Android, we're inside of a fragment, we have to do field injection. Same thing with an activity, a service, stuff like that, provider, anything of that nature. All has to be field injection because we cannot inject through constructors inside of Android components. However, for regular plain old Java objects, POJOs, we can do constructor injection, and this is what I highly recommend, because you cannot use one of the classes that you need to use without using a constructor, without saying let's go to an example. For example, we not use the logout service. We say logout service, logout s whatever equals new logout service. If we don't provide the context in the account manager here, we can't create this with service. So we know that to build a logout service, I need a context and I need an account manager in order for logout service to do its job. Now, I can actually create bindings inside of Dagger to say, hey, when someone asks for the context, the Android context, just go ahead and give them the application context. And when someone asks for the account manager, I want you to go ahead and use the context to build a account manager using the get service method off of a context. And then at runtime, I can just ask for these two things, and then I can go do whatever I need to go do with the context and the account managers and so forth. So what I highly recommend is, Dagger is a huge topic, and we could go into it for 2 or 3 talks, and we would probably still have more time. Probably need more time to still explain it. The big thing is it's dependency injection. It helps you break your dependencies. I highly recommend that you start using this today. It'll provide you with an instant reward. It gives you tons of flexibility, gives you tons of ability for composition, and allows us to do testing. Now, one of the things that we see here is that we have Dagger is such a big topic. We notice that we need a lot of information about it to understand it. And so there's a very good deep dive here on SpeakerDeck. And if you go to speakerdeck.com/Jake Wharton, you can see the actual Android apps with Dagger. Jake also has a talk that he did at DevOps, which I don't have the link to, but you can. I think it's on parlays.com, which you can actually pay to watch the talk. But these are the slides from that exact talk, and if you're able to walk through the slides, you should learn quite a bit. So now, next big thing is how do we perform in-app communication? Well, I'll tell you what, I sure hope it's not statics, because I've recently dealt with an application where everything was set through statics. Every field was a static, and they just passed values around through statics. Now, when Android was first around, that was what's recommended. However, I highly don't recommend that. It creates a tight coupling between everything and makes it very, very difficult to break apart your application. So it's responsive, and you have a tablet and regular version and fragments and so forth. So the big thing is, let's think about pub/sub. And pub/sub being publish subscribe. And what that basically means is we just need to use an event bus. And let's take a look at a screenshot here. Let's take a look at, here's the MyFitnessPal application. Now let's assume that anytime I click on the little lunch wrench icon in the middle of the screen where it says 241 calories and I add something via that icon or something like that, or maybe I just long press on cilantro lime vinaigrette dressing and long press and delete that item, I need to update the top area here, which is in gray. It says goal, food, exercise, net remaining. These are your calories remaining. I need to update that. Now I could do that by hard coding and wiring it, and maybe it would look something like this. So I would have the view, which is atop the activity. We have a view model, which we passed around, etc. And so maybe I go down to a service and I change a service. Then I have to go up to the model, change that. Then go to the view model, change that. Go up to the customer, change. And I have this big wiring just to change a text value because for some reason I deleted some calories out of my daily intake. So what an event bus actually does, instead of actually wiring up every single item manually, an event bus allows you to pub sub. Each one of these layers inside of your application can then subscribe to various events. So if something in the services layer publishes an event saying, hey, looks like we've deleted some calories, something up on the view can say, hey, oh, looks like I've updated. I need to refresh this, total calorie consumption area, and it will actually know how to refresh itself. Instead of actually having to wire up 3 additional layers just to get to the proper layer up top on your application architecture, you can use an event bus to communicate and facilitate that throughout your application. The key thing is you want to easily communicate inside of your application. So if you have various components of fragments all over the place, you want these fragments to communicate with each other and also communicate with the application Chrome around it. You want to be able to do that without overcomplicating your application. And so one of the that's the great thing about it, but one of the downsides is that you can overcomplicate your application. But see, the thing is, tooling helps, such as IntelliJ and so forth. So you can actually find these things very easily, find where these events are subscribed, find where they're published. Now, what do you use for an event bus? That's the big thing. These are probably the 3 most popular at this point in time. The popular frameworks being Auto, which is from Square. The other one, which is Green Robot's Event Bus, that's his very popular one, has a lot of flexibility into it. And the new kid on the block is RxJava from Netflix. And this is based around the Rx framework inside of .NET. It's very powerful stuff. Right now, I know a lot of people use Auto and a lot of people use Event Bus, but I'm seeing a lot of the larger applications and more well-defined companies starting to migrate to things like RxJava. So definitely take a look at all 3, see which one fixes it for you. So let's talk about this. What is this right here? This is log output from Android. And we can see here we have a bunch of different things happening from the system process. Then we can come all the way down to a null pointer exception on a mount service. See, the thing is, Android logs are not really that great, unless you're formatting them accordingly. But even that's kind of a pain in the butt. So the big thing is I think it's like log.wtf. But the funny thing about this is actually a real method inside of Android. So let's take a look at that. That's kind of funny. So here it is. This is a log class. We have a WTF. They call it what a terrible failure. Okay. Anyway, that aside, but really here's the issue. We have these various different log commands, log.e, d, I, and v. So error, debug, information, verbose, etc. And then what you have to do is provide a tag. And then after you provide a tag, which is kind of like a tag, you're going to say, well, this is how you can kind of go search for it. Then you provide the information you want to output into your log, like, customer is null, customer ID is 12, something like that. The thing is I like to know when this log goes off, I like line numbers. I like things that kind of look like this right here. And this is a log that's it's too long to put on one line. It would be way too small to see, but we can actually see this is actually one line if we could put it in a text file. And it says we have the date, the time, of course, and then we have the package name. We actually see it's D/, so it's a debug log. We can see what file it's in, abstract navigation helper .java. It's on line 370, and looks like we are starting a main activity normally, and we're using an intent. So we passed in an intent. Here's the intent that's used. And the component name and so forth. And so I have a whole bunch of information here. I have the line number, I have the file, the time, the package name, the content of the intent. And so what I recommend doing, and I start with every project, is I don't use log at all. I use a custom class called the LN logger, and I pulled this from ROBOGUICE and Android Bootstrap. And the big thing is that's really nice is that you can forget the tags. So no more of this a log.tag. You just say ln.d, and then you pass in whatever you need to log, and then it'll actually output all kinds of information. So here, the only difference with the ln.e is you pass in the error first and then some text. And now the cool thing is, ln.java provides all kinds of information, such as file names, line numbers, the package name, default. It defaults to verbose logging for debug builds, and it builds in string formatting. So on the previous screen here, we could actually say ln.d, and you can provide it in the quotes here. You could put a string format. And then after the quote, you put a comma and then the values of the string format. And so you can actually do string formatting right inside of the ln.d. And so it provides all kinds of good information. And you can get ln.java from either RoboGuice, or you can get it from Android Bootstrap, which I will talk about in a little bit. But the big thing is actually getting yourself to implement better logs that are much more readable and much more useful as a developer. Another thing to help with logging is a library called Hugo. It's annotation-triggered method call logging for your debug builds. And you can see here, this is a method, and we've annotated it with a debug logs annotation at the top of the method. And what this will do is, if you see in the result, at the top of, as soon as the method is executed, getName was called with the string value of first being Bill and the string value of last being Cosby. And then afterwards, looks like getName returned in 16 milliseconds, the string Bill Cosby. So I can actually, at runtime, get this information in debug. So we don't actually have to write the log statements. The Hugo library will do it for us, and we'll only do it inside of debug builds. You can learn more about that at Jake Wharton's GitHub page at github.com/JakeWharton/Hugo. Now another thing, if you need to build your application and you have a website, or you want to be able to have other apps interact with your app, what you need to think about is deep links. And what deep links are, deep links allow you to properly open up your business opportunities and growth. And what I mean by that is you can actually expand your application reach by having deep link support, because you can work with partners and they can fire off various intents, will open up your application, and if they send the intent over properly, your application will perform some type of action. Now you have seen this type of different types of interactions of various applications. And so the deep link is just the URI that's intercepted and is responded to. And you've seen things like this inside of Twitter. So if you click on a tweet on a web page, you'll see your Twitter app open sometimes. Same thing with YouTube. It'll say, do you want to open this with YouTube, or do you want to look at it with Chrome? Google+, Groupon, and many more do the same thing. So if you click on a link, it opens up the app, so you actually get inside of the app. And that actually helps increase customer retention and app interaction levels as well. It helps increase those as well, and user retention. So let's take a look at what one of them looks like. You have two different kinds. You have a URL-based one, which is just kind of, if we go to a website like DonnFelker.com/somepath, and then you can also create a custom deep link, which has a custom scheme. This one is DonnFelker/path to something. And so you can either respond to either one of these. If you want to do app-to-app communication, you're probably going to want to use some type of custom deep link, and you want to build that inside of your app. If you just want to be able to open up your app when someone clicks on a link on a web page and have your app intercepted, you want to use the URL base. And sometimes you want to do both, so you want to include both here. And this is what it would look like inside of your Android manifest to do that. And so what I usually do is I usually like to build an activity. I call it the deep link router activity. And inside of this router activity, I intercept the link and I get the content, the data that's sent in. And I see if it's a link from DonnFelker.com or if it's a custom one, such as a Donn Felker scheme. And that's shown down towards the bottom of the intent filter here, where we are specifying the actual intent filter. So if for some reason in the intent, someone has the scheme Donn Felker as a URI, then go ahead and intercept it. And now if someone also has the host of www.DonnFelker with a scheme of HTTP and with a particular path, which is just an ellipse right now for brevity, then go ahead and intercept this, otherwise ignore it. And so what this will actually able to do is drive engagement by someone opening your app via a deep link. And so this is very, very useful. So you can actually have apps, maybe you have a third-party network of apps that interact with your app, such as maybe MyFitnessPal might, or you might have an ad network and you want to be able to open up various different ad frameworks or various different, advertising platforms based upon a deep link that's passed in. Or you have different types of users, anything of that nature. Deep links are very valuable for tracking and opening and keeping user engagement high. All right, now let's talk a little bit about fragments. Fragments, these are the recommended UI approach for building Android. And the thing is, most people don't think about fragments. They don't think that they need them right away. They think that we'll just build our application with activities and we'll move to fragments now. I highly recommend you move against that. If you don't think you need them, you probably do need them. And so build with fragments immediately. And see, the thing is, fragments are good for a lot of things. One of the really good things they're used for is responsive layout. So if you develop everything in fragments, you can build a responsive app real easily. And what I mean by that is an app that looks good on the mobile phone as well as a tablet. And so it's much easier to build that when you already have everything in fragments. If everything's in activities, it's a real pain to extract it into fragments and then build it to be responsive. But if everything's in fragments, it's actually much easier to create a kind of a bootstrap activity that determines, hey, am I on a tablet-sized app device, or am I on a phone-sized device? And depending upon which side you're on, then you can just follow a different code path to say, all right, well then open the tablet homepage, open the tablet home screen, or open the phone home screen. And at that point, maybe one fragment's shown for the phone and two master detail view is shown for the tablet. Much easier to do. So that helps with the screen and UX composition. You can also, once you build fragments, you can host fragments inside of fragments. You may have a custom date picker that you like to use when people swipe. It does this nice cool animation. You can build that as a fragment, and then everything that uses maybe some date logic, you can include that fragment inside of the other fragment. So you have a date fragment inside of maybe a news list fragment. And so you can have a date fragment inside of a daily calorie goal fragment, and all those things. So you can start putting these these fragments inside of fragments, because you can use child fragments inside of Android, the support library, as well as new versions of Android. Fragments make view pages easier. So you want to swipe left and right, and you want to have various different fragments show in and slide in and out, very fluid. View pages work excellent with fragments. It's much easier. And then, of course, you have your sliding drawer, which is kind of a common pattern now for Android navigation. The left-hand side should be a fragment. So when you do go into a responsive layout, you can actually just plop the fragment on the screen. You don't have to use a sliding drawer. So it's very easy to just use a fragment for the sliding drawer itself, and you just wrap it inside of a drawer layout. Pretty easy. So the big takeaway here is start with fragments, or if you haven't, just go ahead and start doing it now. Because if you wait till later, it's very, very expensive. 3 to 5 to 10 times as expensive to move to fragments later if you have a huge hodgepodge of spaghetti mess that we've talked about before. So do it sooner than later. So let's talk a little bit about continuous integration. Continuous integration is something that I highly feel is necessary for even teams of one person. A lot of people don't feel that way, but I feel that even having a continuous integration environment set up just for yourself will show you the things that you're missing from your process. You may be missing a library, you may have forgot to add something, you may have configured something in your local environment that you forgot that you need to configure elsewhere. So when the next person comes, it's difficult. You can run your unit test to make sure you didn't break anything. In the end, it's basically a core component for any team out there. Now, there's a few options out there for continuous integration, and we can go into various different talks about this. This could be a whole talk in itself on just one of these here. So you can use Jenkins, which is open source. You can use TeamCity, which has a professional license of up to 20 build configurations, I think. And so I use both Jenkins and TeamCity. You can use Travis, and you can use a bunch more as well. And Travis CI is what I mean by Travis. There's a whole bunch of them. Circle CI, hosted solutions. If you don't want to host your own, those work as well. I'm not sure if they do Android, but these are the ones that I know that work with Android very well. Now, the most common they're going to be Jenkins for in-house. So if you have an in-house build server, or maybe you're even hosting on EC2 for your company, you're going to see Jenkins is going to be the most popular. This is what has been used at the various companies that I've worked at. Now, if you're in the open source area and you want to use a build server, you can use the Travis CI build server, and I've used this to build Android applications as well on Travis, so that also works very well. Big thing is get a build server as soon as you can. Make sure your unit tests are running if you can. If you can get your integration tests running and your spoon tests, and you can get all that working, even better. Then you can automate a lot of that stuff and then get reports as things are happening throughout the day, and you don't have to worry about running it right before release and realizing you have 50 build errors. Always have it run on every single commit. and you're going to thank yourself later. It's such a valuable tool that no team should go without it. What gets measured gets managed. This is a saying that I use all the time at every client that I go to. How do we know what we should change if we don't know what's happening right now? And so what I mean by that is analytics and A/B testing. And first we'll talk about analytics. And so a lot of the typical analytics that you use on mobile applications are going to be Google Analytics, local analytics, mixed panel, or some type of custom solution. You'll usually see the custom solution implemented when you have reached the threshold where it's too expensive to use a third-party tool, or the third-party tool does not provide the insight that you need, so you end up building your own solution because the third-party solutions are just too expensive anymore. Now, for these types of things, I highly recommend initially just tracking which screens are open. So just track a screen view. So that's going to get you your low barrier to entry. Pull in Google Analytics or local analytics and just start tracking each time a screen is viewed. That's going to give you the basic information to see what part of your application is being used the most. You're going to find out that maybe there's a settings page that 80% of your users end up on. Why is that? Maybe everybody wants to turn off the notifications for some reason. I don't know. But that's something that you may want to know instead of Google Analytics. And you won't know that until you're measuring it. So be sure to install some type of analytics inside of your application. So it's going to help you predict and see what your users are actually doing at real time inside of your applications. Now, another thing that you can do with analytics is A/B testing. This is a very common thing in the web world. We A/B test, we're going to use this text here. We're going to, in this 50% of the people are going to get this, 50% of the people are going to get this text, or you're going to split it up across various different variants. So can you do A/B testing on mobile? Well, yeah, you can. You can do it, but a lot of times it's custom. And here's what a typical custom kind of implementation looks like. You maybe have an API at your company, and you have when the application starts up and the user registers, it's a configuration type of API or something of that nature. And it sends back information about this user, and it's random based, so the variant is given a particular value or something of that nature. And it says A/B test. It sends down an array of A/B tests, and this one might be called 2014 April login button color is your A/B test. You want to test the interaction based upon the login button color. And the first one's called orange, and the color of the button is going to be this hexadecimal value. And then there's another one called yellow, and you're just going to basically switch between the two. And you may include additional variations here saying 50%, 25% local. And so sometimes the custom implementations can range. You're going to have to do it manually, and that can be kind of a pain because you might have to adjust this JSON back and forth. You have to build your applications. But what ends up happening is most of the time it's going to be custom because the third-party implementations are very expensive when you start getting to scale. And you have hundreds of thousands of users or millions of users. It's just not cost-effective to use a third-party tool unless you have some type of deal or pre-arranged with them. And so you end up building an API that returns your A/B tests and your variants, and then at that point you have to implement the code inside of your application in order to execute on top of those variants that come down. But what that allows you to do is determine, hey, does this button have more interaction based on its orange or if it's yellow? Who knows? Now, if your application is just starting out and you want to kind of get a quick glimpse into what A/B testing can do for you, you can use one of these third parties who've already built these nice visual optimizers. And if you've used anything for the web like Optimizely, you'll find that some of these are just like that, but for mobile apps. And so you can use Optimize, Arise, Lean Plum, App Iterate. A lot of these provide a visual editor where you can change text at runtime. So you drop the SDK into the app, you publish it to the App Store or Google Play, and then at runtime you can actually change the text of these to say 25% of the people should get variant A, 25% of the people should get variant B, and 50% should get the control value. And at that point, you can start seeing what's converting more. It looks like more people are actually clicking on the, based upon the statistics of the traffic on that particular screen with the tests that you're running. It looks like more people are clicking on the yellow button than the orange button. So that makes it a lot easier to do testing and so forth. Let's talk a little about community. So the big thing is I tell people to embrace open source. This talk could probably go on for another 3 hours if I wanted to cover everything that I want to talk about. But a lot of things are done inside of open source, which I heavily rely on. And I like to stand on the shoulders of giants. And to do that, I use a lot of libraries that are developed by other great individuals. Some of these are Dagger for dependency injection, Auto for message bus, Picasso for image loading in Android, and network communication image loading. That's great. OK HTTP and Retrofit for API communication and HTTP communication. Spoon for testing. Another HTTP library I like to use a lot is HTTP request. We have RxJava for event bus type stuff. JSON and Jackson for processing JSON. Guava has a bunch of utilities. Butterknife for view injection, which is really nice. Hugo, which also has some other nice tools. We have Timber, Mage, Scalpel, Stagger, Grid. The list can go on. This can go on and on and on and on. These are all various libraries that you can use. And where you can learn about a lot of these is inside of the open source libraries that they're in. And so that's how you can also help bootstrap your application. So if you're not in the top 100, how do you get there? I mean, you can bootstrap your application to use something very nice. And that's going to be various different options that you have. And 3 of these great options that you have are going to be Android Bootstrap, which is I'm actually the main developer of. You also have Android Kickstarter and Jake Wharton's U2020. So let's talk about Android Bootstrap. Android Bootstrap is basically a template application that allows you to get up and running with a bunch of popular Android application libraries. This includes uses of fragments, fragment pager, responsive layout, action bar, app compat, support back to Android 2.x, navigation drawer, view page indicator, HTTP request, JSON, some old Robotium stuff, and I actually consume an API up on parse.com. The nice thing about this is you can go to androidbootstrap.com, provide the application name that you want and your package name, and I'll generate the entire project for you, and it downloads as a zip file. So you don't have to do any renaming of the packages or folders or application. It just comes out and it's ready to use. The next one is very similar. It's called Android Kickstarter. And Android Kickstarter, you can plug in the same thing, application, package name, and the main activity name. And you can actually configure here. Do you want to use Maven? Do you want RoboJuice? Do you want Action Bar, Sherlock, etc.? So they give you a little more flexibility into starting your application. However, the libraries are a little bit different. So some people prefer Android Bootstrap. Other people prefer Android Kickstarter. Either one of them will help you get going with your application looking pretty good very quickly. And then finally, we have the most recently released Jake Wharton's U2020. And this is a demonstration app based upon various different tools that Jake Wharton uses, such as how to use RxJava, Dagger, Hugo, and a whole bunch of other libraries. And this is actually an animated GIF of the application running here. And you'll actually see that he shows the staggered grid, which is from ETE, and so forth. And Picasso is loading the images and fitting them as they are able to come in. And it's a great example of how to use them. Now, there's no generator for this application yet. Well, I don't know if there ever is going to be one, but the options, you can see here, there's a bunch of debug development options. There's a bunch of cool things happening on the app, and this is how you can come take a look at it and see how to use some of these tools in a production environment. The thing is, read great code. That's one of the best ways that you're going to learn things on a day-to-day basis. And that's the best way that I've learned, is find some great developers out there. Any of the guys from Square are great to follow. A lot of the Google code is great. Etsy has some great stuff out there as well. Start following various projects on GitHub, and you're going to start learning a lot of stuff on there. Just follow them to your watch list on GitHub, and then every once in a while go check the news feed, and you'll see if someone is, maybe if one of your followers has starred another item, maybe you want to go check out that library, see what it's about. You'll start finding all kinds of great stuff out in the web. There's also other newsletters like Android Dev Digest that you can join at androiddevdigest.com to send out weekly newsletters of all the great tips and tricks for Android developers as well. And that kind of wraps it up. The big thing is here is there's a lot of things that we've covered and a lot of things that I still haven't covered. But these are the most important things, and these are the lessons that we need to prepare for when we have an app in the top 100. Number one, you need to prepare for things to break. Be prepared by having Crashlytics installed. Make sure you have unit tests backing it up. If you fix something, write a test for it so it doesn't break next time, because it will break again if you don't write a test for it and your developers don't catch it. Number two, prepare to support your customers. You're going to have an influx of new customers with feature requests, with various different complaints, support issues, etc. Be prepared to support them. Use a tool like Help Scout, Zendesk, Desk.com to help automate the workflow of your support process for your customer service team, your customer help team, or whatever you may call them. This is key. Without your customers, you're not going to remain in the top 100. And third, remind yourself to stay foolish and stay hungry. Just because you're in the top 100 right now doesn't mean that you're going to be there next week or a week from now or a month later or even a year later. You're there right now and you need to stay there. So keep iterating, keep developing, and keep making things that other people are afraid to make, and keep doing what you're doing. Thank you very much. If you need to reach me, you can reach me at Twitter at Donn Felker, or you can email me at don@donnfelker.com. Thank you.